Hi everyone, I'm Megan Marsh. I'm a principal engineer here at HashiCorp and the engineering lead for Packer. Today I'm going to talk to you about the HCP Packer Registry, where we are with building the product and where we're going next. So the first question to answer, of course, is what is the HCP Packer Registry? And the answer is that it's a hosted service that will bridge image factories handled by Packer and image deployments handled by Terraform to help create image management workflows and allow development and security teams to collaborate on golden image pipelines. The goal of the registry is to store metadata about your golden image without storing the image itself so that we can track the relationships of the images to each other, information about the images themselves, and make it easy to automate the creation of those images and the use of those images, introducing cross-cloud versioning to your image factories. So the first workflow that we think will be really valuable for this cloud platform is one that bridges Packer and Terraform, or really any image creation and instance deployment that you may have at your company. As we all know, Packer builds, create, and package golden images. We want to use those golden images in our Terraform plans, but there's a disconnect here because the question of how to get the output out of Packer and into Terraform is generally left for practitioners to figure out. So out there's a lot of bash scripts shoved into CI, pulling the AMI ID for an image out of a manifest file that Packer has spit out, or there might even be operators copying and pasting those values into their Terraform plans. But of course, this is also oversimplified because in reality, we don't necessarily want to automatically pop the output out of Packer and straight into Terraform without some kind of validation. We want to be able to copy this AMI ID first into a test suite and validate it there before then copying it back into Terraform again, which means that there's multiple places that we need to track it. And in that situation, we need to make sure that we handle the situation where if a Terraform plan is run before an image is validated, but after it's built, then the Terraform plan is using the most recently validated image and not the most recently built image. And that means that figuring out which version of an image to use is really important. So this is where the HCP Packer Registry is going to come in and make this a solvable problem. The HCP Packer Registry sits in the middle of all of that. It's a centralized tool where you can keep track of the images in a versioned way that allows you to pull the image you want for a given point in your pipeline, keeping track of what your pipeline needs at that moment, and then keeping the rest of that pipeline unblocked. So the way that we do this is every time you run Packer build, you create a new version of an image, and then you run it again and you create a new version yet again. We keep track of all of these images in the registry. And then, depending on the maturity of the image that we're talking about, we can use the HCP Packer UI or its API to assign different release channels to each of those images. The acceptance tests don't need to know the exact AMI ID of the golden image that they're testing. They can be confined to know that they just need the image pointed to by the testing channel. And if they reach out for that testing channel, they'll retrieve the image that we have marked for testing. And the same goes for instance provisioning. Terraform will ask for the production version of a golden image, and it knows that it's always getting the most recent vetted image for production. And then, when this test image finally is fully vetted in CI, you can promote that to production. And then you can upgrade the pointers so that now the acceptance testing suite is pointing to the very newest build, and the Terraform production channel is pointing to that newly vetted, newly promoted image. Another use case you could have would be making your golden image factory itself more seamless, leaving Terraform out of the problem altogether. So for example, let's say that your security team has a special base image that they've hardened for use in your entire company, and they have a special Packer template that just defines this base. Now, on top of that base, you may have a secondary layer that installs all of the dependencies related to what that image will be used for, and this layer is also defined by a separate Packer template, and that template uses the base image produced by your security team as a source, and it spits out an entirely new image that you need to keep track of. And there may even be a third layer on top of that with other app-specific dependencies, depending on how complex your pipeline is for your company. So the question then is, how do I know which version of each of these layers to use when building a new version? It's the same question as we had with the Terraform suite, with acceptance testing and wanting to make sure that you have something that's valid for your given situation in your pipeline. And so yet again, we can use Packer channels to figure this out. The other great thing about this is that with a couple of clicks, you can also see which source image was used for a given version of a given secondary layer, which can give you great insight into whether downstream layers are affected by upstream issues with a specific image version. So now I'm going to walk you through a workflow where we use Packer to push a base image layer to the registry, and then we retrieve that base image so that we can build a secondary layer on top of it, push that secondary layer up into the registry, and then use that secondary layer in a Terraform run. I've named these examples as though we're building an ice cream sundae, which all the best of them are made of layers, just like all the best of our Packer builds. So I'm going to start with the vanilla ice cream layer, and once we've pushed that to the registry, we're going to retrieve it and add a layer of chocolate sauce on top. So let's start with our base image. Here you can see a simplified example of an HCL Packer template. Now, before I get too far into this, I do want to make it clear that you can use the HCP Packer Registry with JSON templates, or at least you can push metadata to the registry with the legacy JSON templates. You will have to set a couple of extra environment variables though. And anyway, what I'm doing here is associating this template with a grouping of versioned images in the HCP Packer Registry, which we call a bucket. So in the registry, when I'll show you the UI pages in a little bit, a bucket represents a single template being written and configured. If you don't set a bucket name here, it's going to default to using the build's name if that is set. And then once I've configured the bucket and described what it's for in my template, I can set a few environment variables here to tell Packer which HCP service principal it needs to be using to push up to, and we can build just as normal. Now, assuming that this build runs and completes successfully, I want to take you through what this would look like in the HCP registry UI. Here you can see an overview list of image buckets. Now again, each bucket corresponds to one Packer template, and therefore a single set of provisioning runs against a builder or a set of builders that you've defined in that template. So we just created this vanilla image, which corresponds to the bucket name in the HCP Packer Registry block. If you have more templates and more images defined, and you've pushed all of those to the registry, you end up with a long list of lots and lots of different buckets that you track in your metadata service here. This vanilla image is going to be the base image for our sundae, so let's click on it to get a high-level view of what kind of information we actually pushed to the registry. This overview page lets us see some basic information about the image bucket, including what's this information for, or what's this image for. We have a description. We can also fill out other stuff like labels. And those metadata labels can include all kinds of good stuff, including who created the image, maybe an email address you can reach them with if you have any questions about what the image is for or what to do with the template. We also can have any number of other labels. We can link it to a Git repository. We can track what version of a particular package is installed. We can track all kinds of stuff. I mean, the world is really your oyster here. For now, those labels are just here to help you get a clear idea of what the image is used for. In the future, we plan to allow you to actually filter images in a query against the API so that you can pull images based on the values of certain labels that you've set and defined. We can also see, if we drill in and click on this iterations tab on the left-hand side, what the latest iteration of the image has, or what all of the iterations are for this image. So here we have a list of what would be all the iterations if we had run this Packer build more than one time. As it is, there's only one iteration showing. Now, when I say iteration, what I mean is a single run of a Packer build or a single successful run of a Packer build can be thought of as a single iteration or a single version of that build. So over time, as you run Packer build to create an image and then change your template and run Packer build again and then change your template and then run your build again, every one of those times that you run Packer will be one new iteration. And so as time goes on, this list will get longer because Packer, the HCP Packer Registry will continue to track all of those iterations across time. Now, this particular list is obviously not very exciting yet because we've only pushed this image to the registry just now. We don't have a lot of iterations to look at, but let's click into that version 1 iteration and see more details about it. Here we can see all of the information associated with this iteration, including the incremental version, in this case version 1. If we pushed another iteration and it was successful, that one would be named version 2. On the right-hand side of the screen, you can also see a list of the individual builds and regions that artifacts were created in. So if I click this drop-down toggle for US East 1 on the right-hand side, you'd actually see the AMI ID associated with that build. And it's also worth noting here that if you had multiple regions defined, you would see more than one region listed here, and you would see more than one AMI ID listed here. Alternatively, if you also had this build defined or a source defined for Azure or Google Cloud, and you were building this same Packer template against multiple clouds, you'd also see all of the builds associated with those clouds. So essentially, these builds on the right-hand side have a one-to-one relationship with a particular image source or region. So you can have one build in an iteration, you may have many builds in an iteration, and the registry will track that data and lump it together to give you that cross-cloud versioning that we were talking about before. I want to be able to reference this image from a Packer Terraform run, and if I want to do that, the next thing we need to do is assign a channel to this iteration by clicking Channels on the left-hand side and then clicking in here. Now, when I talked about channels earlier, remember that this is essentially a mutable pointer associated specifically with your image bucket. And a channel can only point to one iteration at a time. And assigning a channel in the UI is as simple as clicking this New Channel button and assigning an iteration number to it. Now, you can also do this by hitting the API directly instead of going into the UI if APIs are more your cup of tea. If you want to do that, if you want to update a channel automatically as part of, say, an acceptance testing suite and say, hey, if the tests are passing, go ahead and automatically update this channel to production for me, you can do that via the API. We actually have an internal team at HashiCorp already implementing that workflow, and it seems to be working out for them really, really well. So we want you to be able to do what best suits your needs, and we will be publishing API documentation for all of the public API so that you can interact with this as you want. Now at this point, we've created our vanilla base to our Sunday, and we've pushed the metadata for that vanilla image up to the registry, including the AMI ID for the image that was produced. Now what we want to do is build a secondary layer on top of that where we add some extra configuration, in this case, chocolate sauce, to the image. So building a second layer means that we need to retrieve that first layer out of the registry, and to do that, we're going to use data sources. Now, because we use data sources, this next example only works with HCL templates, whereas previously we were just pushing metadata, now we're pulling metadata. If you want to do this image pipelining where you pull metadata from the registry in Packer, you're going to need to move off of JSON templates. Now's a great time to upgrade, and remember that you can do so using the HCL2 upgrade subcommand to convert your templates to HCL. Now, if you need more convincing, I did give a little talk at HashiConf EU about all the reasons you should upgrade, so I really recommend you check that out if you're on the fence. Back to our HCL template. Now remember, this is a new template. We're building one for the chocolate sauce layer, not for the vanilla base layer. This section of a template is going to start out by showing us some data sources. Now, this first data source pulls information from the registry about the iteration, that is, the previous Packer run that was run. And then this second data source uses information, specifically the iteration ID of that run, and uses that to retrieve the specific build in the specific region and get us the specific AMI ID of what we want to use as our source image. At that point, we can use the image ID as our source AMI in our Amazon definition, and then we can go through and build our Packer build as normal. Now notice in that last view, you didn't have to actually know the AMI ID. All you had to know was the region you want to build in, the cloud you want to build for, and the channel that you want to retrieve. So at this point, we're going to go through, and in the HCP Packer Registry block, we're going to define a new bucket, because again, this is a new template with a new layer. It gets its own bucket. In this case, I'm not going to show the provisioning because I'm going to leave that as an exercise for the user. But the key takeaway here is that we are using data sources to retrieve that Amazon image ID from the first bucket, and we're going to use that to create a new bucket. So we're going to run Packer build just like we did before. And as luck would have it, I actually made a mistake when I was running the builds to grab the screen grabs for this talk. My Amazon credentials expired, and so my Packer build for this secondary layer didn't actually complete. I popped onto the registry UI for a view of what you would see if this happened to you, and an iteration didn't successfully finish. As you can see here, the iteration has been grayed out and marked incomplete. You can't access it, and you can't assign channels to it. Now, this is because the registry knows you didn't actually get results from all of the builds you defined in your Packer template. And notice that it also doesn't have a version number associated with it, like version 1, version 2. It just says it's incomplete. We don't give those incremental version numbers to iterations until they're complete, as yet another indicator that you shouldn't be referencing them because they're still in progress. Now, the good news is we can just rerun. So here I refreshed my Amazon credentials and I built again. And this looks more like what we saw before. We built a new version of our chocolate sauce layer on top of our vanilla ice cream layer. And if we want to, from here, we could get a third bucket and build a third set of layers on top of it, you know, adding sprinkles or something, using the same process that I already demonstrated. But for now, I think you've got the idea. So what we're going to do is look at what happens if we then change the base image. So let's say that we needed to make some kind of a change to our vanilla base. In our original template, this is our original vanilla template. Now in real life, there's a lot of reasons why you might actually have to make a change like this. You might have a dependency update. You might just have rules around how frequently you need to rebuild. You may have a major vulnerability that needs a patch. In this case, I needed to apply a patch because it turns out that the word Sunday, when we're talking about ice cream, is actually spelled with an E. And this was a pretty major provisioning error, so I had to go fix it. And now we're going to rebuild the image by calling Packer build. But if we just rebuild without committing, we'll experience an error. And that's because Packer checks locally to see if your template is in Git and uses the commit hash as a fingerprint if it is. That way it knows if it's intended to push to a new iteration or the same one as it was pushing to before. Now if I don't commit here before I return, or before, Packer is going to show an error that says, hey, by the way, the iteration that you associated with this commit fingerprint is actually already complete. You can't push new images to it because there's nothing left to build. This is a safeguard to prevent you from overwriting existing iterations that may already have release channels associated with them. Now, if your templates aren't in version control, you can work around this by manually setting the desired iteration fingerprint in an environment variable instead of relying on a Git commit, and that environment variable actually overrides the Git fingerprint if you are in Git also, so that you have ultimate control over what you want to consider a fingerprint for your template. Now, if we commit our changes, we can rebuild. And then it'll allow us to push. Now, once we've pushed our image, we go to the registry and we can change the release channel to point at the new iteration using a couple of clicks. So we go into the channels, we click change assigned iteration, we get to version 2 of this iteration, and then we can click update. Now this means that any builds that depend on this bucket's production channel will now pull the new images associated with the production channel, not the old images associated with the production channel when it comes time to rebuild. And this is pretty cool because if different teams own different layers, the team that owns this layer can govern what image your downstream users are using. And if you are building a secondary layer, you can govern what downstream users of you are using. And it's doing this in a centralized way that doesn't require users to actually have to know if there's been something like a security patch. They don't have to check because Packer will automatically check for you. So you don't get tangled up in worrying what things are. Now, we've updated our production pointer. Downstream consumers are going to be able to rebuild, and in this case our chocolate sauce layer is going to be able to rebuild without having to change our templates at all. Because the image ID has been abstracted away, we don't have anything to change. We know that the region is still the region, we know that the production channel is still the production channel, we know that we still want to pull from the vanilla bucket. When we rebuild, it's going to rebuild based on that vanilla base without any further work, and it's going to use version 2 to do it. And the whole process works the same way for Terraform. Even the two data sources that we use for the Terraform plan are nearly identical to the two that we use for the Packer plan. And this means that your applies can be guaranteed to retrieve exactly the image that you're supposed to retrieve for any given environment in a way that's actually governed by the HCP Packer Registry, maybe even its UI, rather than at the Terraform apply level. So if you want to use the HCP Packer Registry in Terraform, the first thing you need to do is get a provider with the minimum version that knows how to reach out to the HCP Packer Registry, which is version 0.17. And at this point, you can create the data sources. Like I said, they're nearly identical to the Packer ones. You first request the iteration, using the channel name and the bucket name, and then you request the image ID using the details about what particular provider and region you want to be building in. And then from there, you can access the AMI ID by changing the Cloud Image ID field, or by setting this Cloud Image ID field on the provider. So here, this provider is just printing the ID out to the output, and here you can see from the call to Terraform apply, you did indeed retrieve the desired AMI. So this entire workflow is going to be a really great way of combining all of your elements of your Packer pipeline and your image pipeline. And the really exciting thing is that I can announce today we're in public beta. We're officially entering this period for the registry. Everything you've seen up until now is a workflow that we currently support, and you can get set up on your organization today. As of today, all of our documentation for this registry is going live. All of our API docs are going to be going live, and you can sign up. We are set up to support all of the official HashiCorp builders for AWS, Google Compute, Azure, and VMware clouds. We'll be adding HCP Packer Registry support to Docker as well very, very soon. If this sounds like something that's interesting to you, I would recommend that you go to this URL and sign up for the beta today. Now, this is one useful workflow, and I think a lot of users are going to find it absolutely game-changing in terms of being able to keep track of how things work in their teams. But this is something that is a starting point, not a finishing point. And we have a pretty long roadmap of new features planned. I want to tease a couple of those features here for you so that you can see how we're thinking about the places we can go next. The purpose of this registry is not just to make image pipelines smoother, as shown in this workflow, but also to make them safer. And so for now, we're going to be focusing on auditing and security tools around this registry. We know that images are part of the HCP Packer registry, and because we know what images are built in them, we can draw connections between the different layers of images, making it easy to visualize how images are related to each other and show dependency trees for you, which is going to help you for things like remediation in case of dependency problems. We're also going to create deprecation workflows. These are going to allow you to set expiration dates for your images so that you can be warned if an old image is being used when you should be using a new one, or even flag images as insecure if they're affected by vulnerabilities. You are going to be able to create rules that prevent pipelines from being able to retrieve flagged images, and you're also going to be able to set sort of basic time to lives in case your organization is one of those that has to rebuild an image every 3 weeks in order to stay in compliance. We're also going to track images, how they're used, how they're created, who updates them, who modifies channels, and more, so that you have an extremely clear trail of access. And we think these audit logs will give you a lot of comfort around knowing where your images are coming from and where they're being used. I can't tell you everything that we have planned for the registry, but I can tell you that I'm really looking forward to building it for all of you. So I wanted to say thank you for your time. I hope you all have an amazing HashiConf, and I hope this was helpful for you, and I really hope to see you in the public beta. Talk to you soon.